Okay, so in this problem, it says graph the function, then use the graph to estimate the local extrema of the function and to determine the intervals on which the function is increasing. Okay, so there's our function. I would rewrite it so it has a common denominator. So I would say 6 plus x squared over 3x. Now, a couple of things you want to note on this. One, this isn't going to equal 0, so f of x does not equal 0. You can see that the numerator can't be 0 with a real number. And then also x cannot be 0, right? Because that would be divided by 0, and we can't have that. So if I go ahead and make like a little piece of graph paper here. So let's count 1, 2, 3, and 1, 2, 3. 1, 2, 3, 1, 2, 3. Okay, well, just kind of eyeballing it there. And I can get a rough graph, at least a little bit here, if I plug in some values. So let's make a little table of values here, x and f of x. We already know there are going to be asymptotes on the x-axis and the y-axis. Okay, and then we can plug in some values here. Okay, so let's say I put in 1. I'm going to get out 7/3. And I can graph that point. So 1 and 7/3 is what? 2 1/3. So it's going to be like somewhere up there. And let's plug in 2. And I'm going to get, let's see, I think I get 10 in the numerator over 6. So that's going to be 5/3. All right. And 5/3 is what? 1 2/3. So maybe it's down around here. Now I can go ahead and put in 3 and we'll see what I get. Let's see, what's that? 15 over 9. Make sure I did that right. 9 and 6 is 15. Yeah. 3 times 3 is 9. Okay, and that reduces to what? 5/3. Okay, so something's going on there. We don't really think it's constant, but it's probably coming down here, you know, going a little lower and then coming up. And we don't know how much it's coming up at this point. It looks like, though, there's going to be some sort of minimum right in there. Okay? So min. We didn't do any negative values, so I would do that as well. It's not going to change a whole lot. If you plug in -1, you're going to get -7/3. I mean, yeah, it changes to negative, but -2 is going to get you -5/3. And then -3 is going to get you another -5/3. Okay. So let's see what that looks like. -1, 1, 2 1/3. So down here someplace. -2, and we're getting what? -1 2/3. So maybe right in there, maybe. Somewhere. And then here. And so it's looking like it's going probably a little bit higher there. So it looks like we're getting some kind of, I should put arrows at least on here. We're getting some kind of maximum in there. Now these are very rough sketches based on a table of values. To get a highly accurate graph, you would need a graphing calculator. There are also apps now you can get on your phone that are even better than the graphing calculators. They have really nice pictures, and they're free apps, and so you can do that. It's not required that you have a graphing calculator for this class, so I wasn't going to spend a lot of time on that. There's some pictures in the textbook you can look at. They just kind of show you, all right, well, here's how you can trace it and find the actual max and min. What did they ask us to do? Estimate? Well, somewhere between 2 and 3 there's a min. So between 2 and 3 is a min. A local min, I should say. And then between -2 and -3, I should say -3 and -2. I should go left to right. Let me fix that. -3 and -2 is a local max. Okay? Where do we think the function's increasing? Well, we think it's increasing then in 2 spots. it looks like it's going to be increasing from like here up to that local max. So from approximately negative infinity to, I'll just say negative 2.5. So that would be an increasing interval. And then another increasing interval is going to be from here on up. So and from 2.5 about to infinity, those would be your increasing intervals. So increasing intervals. So you might want to look in the textbook to see what they did. We were just estimating this based on a rough sketch, and that's how you do that. And we were looking for estimating, again, the increasing intervals. Okay?